Good morning, I'm Sean Clinning. I'm the site lead for the Dow Chemical Facility at Elizabethtown in Kentucky. Today we're at GC Burkhead as part of our STEM program, where we engage with 4th grade elementary school pupils and we give chemistry lessons. All of our engineers and scientists on site come out roughly once a month and spend a morning in our elementary schools giving lessons to our students. Good morning, class.
Good morning.
Cool. So did you come today to have some fun?
Yes.
Wrong class.
Yes.
This is serious science today. Ooh, all right. So my name is Sean, and I'm from Dow, and my colleague, my co-worker Brian has also come down to help. You can ask us any questions. Best way is to put your hand up because then not everybody's shouting at the same time. I talk very fast, and Brian reminded me this morning that I talk fast. I also talk really funny compared to all of you guys. So if you need me to repeat something, ask me to repeat something and I'll repeat it. So today we're going to do some stuff about chemical reactions and we're going to do some stuff about physical reactions. So when we talk about states of matter, does anybody understand what states of matter is?
It's something with like chemical.
Yeah, that's the chemical side, but the state of matter. So if you take a glass of water, what have we got in the glass of water?
Liquid.
Yeah, liquid. Cool. Okay, if I put that glass of water into the refrigerator and the freezer, what's it going to turn into?
Solid.
Solid, right. And if we stick that glass of water inside a kettle or a pot on a stove and heat it up, what will happen?
Gas.
It'll be a gas. Okay, so what are the 3 states of matter? Solid,
Liquid.
gas. Cool. All right, so there are 3 states. What you're going to see today in the classroom and why we pick these experiments, these are part of a national curriculum that Dow works together with other states, and these lessons have been developed to have interest at the year 4, grade 4 level. They are designed to be interactive, they're designed to be simple, and they're designed to be safe that we can carry out in the classroom and have maximum engagement of the kids in the class. It's about having fun and making science fun and not making it difficult. So everybody knows when we take something solid like a chunk of metal or a glass of water and we heat it up, if it's metal, it first becomes a liquid and then eventually it will boil and it'll turn into a gas. We all know that, right?
Yeah.
All right. Does it always happen that way? Oh.
Yes. Yes.
I don't know.
No.
No. So when doesn't it happen that way? Come on, you told me it didn't happen that way, so you got to tell me when and why. Alrighty, first demonstration. Oh, there we got somebody. Thanks, Brian.
It might not work with the cloth.
You're right, it might not work with the cloth. That might just go from a solid into a gas when you heat it up real hot. All right, think about wood. When you put wood on a fire and you burn wood, what actually happens to the wood?
Fire.
What is the fire?
Gas.
It's the gas that is actually catching fire and the oxygen in the air is feeding it. So we don't have liquids after you burn wood. You end up with ash, which is a solid, but you get gas come off. All right. So what about other things that are much purer than wood? Because wood has got a whole bunch of different chemicals in it. Let's take something more similar. Or it's more simple. Have you heard of dry ice before?
Yes.
No. Okay. So we've got some no's, we've got some yeses. What do you think dry ice is? Yeah.
It gets smoke out of the ice.
You get smoke out of the ice. Yeah, maybe.
It's like cold air. It can stick to your skin.
Yep, it can stick to your skin. It can actually burn you, it's so cold. Same way you burn yourself when you stick your hand into hot water or you stick your hand on a hot pot. You'll burn yourself. So we've got dry ice today.
Oh no.
Oh yes. All right. Do not touch the dry ice, right? Safety and chemistry go together. That's why everybody has goggles. We have gloves on the table. And we're not going to touch anything today without gloves on. And we're definitely not going to touch the dry ice. So you'll notice Brian is putting on some really cool gloves because he's going to touch the dry ice with those gloves. And we'll pass some gloves around so you can feel they're not like the gloves on your table. That dry ice is negative 60 degrees centigrade or minus 100 degrees Fahrenheit. So if you touch that, it'll burn you. It's not called liquid nitrogen, but it's not different to it's not that much different to liquid nitrogen. So hang on. So let's talk a little bit about liquid nitrogen. So when you say liquid nitrogen, what's the first word? Liquid. So what does that mean? It's a liquid, right? So we've got liquid nitrogen is liquid, and the other word is?
Nitrogen.
So nitrogen is the gas in the air we breathe. 70% to 79% of what we breathe is nitrogen. The other 20% is oxygen. Right? So when we breathe it in, is it a solid, a liquid, or a gas? Right, cool. But when you get it super cold, it goes liquid. Who's ever had liquid nitrogen treatment at a doctor's? All right. What did you get liquid nitrogen for?
I had a mole on my knee.
Yep. So what did they do with that liquid nitrogen?
They poured it on me.
Yeah, and what did it do to your knee or to that mole? It made it numb. It also froze it. All right. It's so cold that it froze it, and they could take it off. So that's what will happen if you touch the liquid, if you touch these carbon dioxide or dry ice. So there's some in here, and we're going to add some more in here. So what does that sound like to you? Doesn't sound like a gas, right? Does it sound like a liquid? It's a solid. Alrighty, Brian, you want to add some more, and I'll step back. Could you put your goggles on just in case something exciting happens? So let's watch what Brian is putting in here. Have a look at what it is. Alrighty. So, what does it look like to you guys?
Smoke.
So you see smoke. So what is smoke?
Gas.
No, smoke is not a gas. Smoke is actually a solid. So smoke are tiny little particles of solid that are so light they can float in the air. So that's what real smoke is. So smoke is tiny little particles, and that's why if you live near a power station or something that burns a lot of coal, you get a lot of soot comes out of the air. All right, all those solid pieces come out, and if you see videos or things in the newspaper or on the internet, and you'll see folks where there's bad air pollution, they all wear masks because they don't want to breathe in all that smoke and get it stuck in their lungs. So this looks like smoke, but it's not really smoke. It's a gas. Yes, ma'am.
Is it fog?
Fog is microparticles of water vapor that are suspended in the air, like clouds. So fog is just a cloud at ground level. All right, Brian, you want to get the measuring cylinder, and let's get some.
This guy?
Yep.
What is that? Water.
Yep, it came out of the faucet in your sink. And stick some ice in.
Boy.
Stick some ice in. Get the bubbles. Yeah, okay. So how much liquid is in here as this dry ice is melting?
Not much.
Any?
No.
Anybody see any liquid?
No.
Alrighty, I'll bring it around and show everybody. Do you see liquid?
No.
No?
I'm a surgeon.
You can be a surgeon. Right? I don't see any liquid, guys.
Oh, I see.
Liquid?
Oh my God.
And what's going to happen, guys? Oh my word. What is going on in there?
Oh yeah, I've seen several like
There is experiment on a field trip.
That's the result. It's over
Just pour water into it.
because it's like
Alright, so one at a time. What's happening? Anybody give me an idea what's going on? What is going on?
It's turning into gas.
Correct. It's turning from a solid into a gas because the liquid in here is warm enough.
smoke is coming out.
Smoke. No, it's not smoke.
I mean gas.
It's gas.
Can we touch it?
Okay, so I go. Is that actually hot?
No,
Come.
it's probably pretty cold.
No. It's not hot or it's not cold. It's room temperature.
Touch it.
Ooh, it feels good.
Alright. So that gas.
Ooh.
So what's happening to the gas?
It's not flowing gas.
Alright. I'm pouring the gas out of the cylinder, right? Look at that. Why is it falling to the bottom? Why isn't it floating in the air like smoke would?
It's cold.
Not really, because it's cold.
It can't float in the air because the Earth's atmosphere is too strong for the gas to go up, for that to go up in the air.
Kinda right. What happens when you pour water out of a beaker? Does it float in the air or does it fall to the ground?
It falls.
Why does it fall?
It falls because of the Earth's atmosphere.
I heard gravity, not so much. The atmosphere could keep it up if it was really light. Okay, so is water heavier than air?
Yes.
Yes. All right. So if I poured water and it poured and was heavier than air, if I pour carbon dioxide gas and it falls to the bottom, what does that tell you about carbon dioxide gas? No, it's not water. All right. Okay. So let's go back. The logic behind this, right? Water heavier than air will fall down. So we've got water and it's heavy, right? We don't know.
What is this doing?
So it's falling down. Why does it fall? Is it lighter or is it heavy? All right, so it is heavier than the air, and I don't really want to pour the water out. I want the gas to come out. We need to make some more gas. Can you chuck a few more pellets in? Goggles on up front. We don't want to get any splash in your eyes.
Yes.
Alrighty, now we got some bubbles.
We can barely hear the bubbles. I can hear it. I can hear it too.
I think you can hear it. Alrighty, so
The gas is cold.
no, not really. Alrighty, so now it's going to pour. See, it's pouring again. Why does it pour? No, if it was light, it would float.
It's heavy.
Yes, it's heavy. Carbon dioxide gas is heavier than air, so it sinks to the ground. That's why you get the smoke come up or the gas come up, and it looks like smoke, but it's gas, and it'll flow down the side of the measuring cylinder and go down onto the table.
If it was light, it would be going up. But it's heavy, so it's coming down.
That's why it's so satisfying.
Alrighty, so now that we've ascertained that it's heavy and it sinks to the bottom, now we're going to have some fun. I need a volunteer. Oh my gosh, lots of volunteers. Whose name starts with an M? There you go. So easy. Bubbles. Alrighty, gloves on. So there's a trick when you put gloves on. Let me show you the trick. Two. There's a trick. So
Watch him, everyone.
the easiest way to get gloves on, because they stick all over your fingers, is just to go, and then once you've blown in it, you get the glove on easier.
Oh my god.
Do you know how to blow bubbles?
Maybe if I heard it, I would go.
Okay. So guess what you're going to do? You're going to blow bubbles over this container. Oh, look.
What? Anti-gravity bubbles.
Look, it's just kind of bouncing there, isn't it?
I can't see it.
I can see it.
Why is that happening? Super strong bubbles. Yep.
Can you see the bubble?
Yes, and now it's weak now. Oh, that's how you solve the problem.
See it?
No.
Oh, you pop. All right, let's do another.
Right, watch carefully. Oh my gosh.
3 of them. Good job.
There's no water in there. I showed you. There's no liquid in there. Why are they floating?
I know what's happening.
Do you know what's happening?
I think I know what's happening.
Share the secret.
I think that since there's air coming up from the ice, I think that's what's making it float.
But there's no air from the ice. We know the ice in there is dry ice. It's carbon dioxide.
I know what's happening.
Yes, young man.
Gas from the ice is coming up and holding the bubbles.
Kind of. Not entirely true.
Because bubbles go down, and since there's air,
I wouldn't. Personally, I wouldn't go and breathe what's in that container because there's not a lot of oxygen in that container.
Oh.
What did we put in the container? Dry ice. Dry ice is carbon dioxide. When I poured the carbon dioxide out the cylinder, what happened to it? Did it go up or did it go down?
went down.
Why did it go down? Because it was heavy. Cool. Look at that one. Right. So because the carbon dioxide is so heavy, it sank to the bottom of that container. It hasn't come up, and the bubbles are not as heavy as the carbon dioxide. So they are bouncing around on a gas trampoline inside that container.
Good job.
We can.
Good job.
And eventually, if that bubble is stable enough to stay in a bubble, it will eventually sink to the bottom because the carbon dioxide will diffuse through the bubble and replace the gas inside the bubble, and it will make it sink to the bottom. And if we're really lucky and don't disturb it, it may even freeze when it gets to the bottom. And it's it's touching. That's so cool. Maybe it'll freeze. We'll just leave it. Yeah, don't bump the table. We'll leave it there for a couple of minutes, or maybe half an hour. Alrighty. So, is this a chemical reaction or is this a physical change? Physical. Good. What happened? It froze. Look at that. It's actually frozen. That is the first bubble we've got to freeze today. So well done. You are a champion. Look at that. That is so cool. Cool. Alrighty. So now we're going to do something equally fun. Who watches CSI on TV or any crime shows on TV? Do you like them?
Yes, they're trying to make the mammoths come back to life. Ooh. And there's going to be a new one.
Cool.
They can go to Mars.
Cool. And who likes the crime scene stuff when the police go and investigate to see if there's been bad stuff happen? Yes, ma'am. Kinda. So do they ever spray stuff on the ground to look for blood?
No. Yes. Yes.
Yes. What does it look like? They turn the lights out normally, right? And what does it look like? Kind of all goes blue, right? We're going to do that now. STEM is the future of our country. We have a fantastic manufacturing industry that we need to support, and we need to keep kids interested in STEM. We get them in as young as this in year 4. We can see them through elementary school. We work with both Hardin County schools and with Eton Independent schools in their STEM programs. If we engage kids at this age, we keep them all the way through and hopefully get them into speed school up at U of L or get them into UK in Lexington, and they come back and we can employ them as engineers on site. Come on, we got the
Is that water?
No, it's not water.
It's a special liquid.
Right. So that is the same bleach we use at home. There's no difference in this. I need 2 volunteers. Whose name starts with a B? No B's. Oh, careful, Brian.
Sorry.
C. All right, guys. People with C, stand up. Who has the longest name? The longest name with a C.
Chloe, CJ, Connor, or Caden?
Oh, God, I can't count that high. Connor. Right, Connor, you're the first one. Come on up. You're the volunteer, man. Can everybody see the beaker?
Yes.
If you cannot see the beaker, get yourself into a position where you can see the beaker. On 3, you're going to hit the lights. 1, 2, 3. Hit the lights. Oh, what did you see? Oh, my word. Everybody can see it's gone green. Oh, blue, okay. Just checking if you're watching. Cool. It is. Caden, hit the lights, sir. Middle one. So, what happened? You guys are all volunteering on this table. Let's have somebody on the back table volunteer. CJ, you are the other guy with a C name. What did you see?
I'm CJ.
You're CJ. Sorry, CJ. My apologies. What did you see?
I saw that when he was spraying it was turning blue.
It turned blue, okay. Was that a physical change, or do you think that was a chemical change? Correct. If it was a physical change, it would be hard to explain because it was one liquid and another liquid. So those were 2 liquids, and we've still got a liquid. So that was not a physical change. That was a chemical change. All right. How good are you guys at nuclear physics? Oh, I told you this wasn't a fun class.
I'm kind of
It is kind of fun.
Okay. All right. So we have, everything's made up of atoms, right?
Yeah.
Yes. Okay. So inside an atom, in the atom nucleus, you'll have the tiny little microparticles that you cannot see with the human eye. Some of them are called protons, some of them are called neutrons, and some of them are called electrons. Oh. So what's happening in here is we're exciting those electrons and we react them chemically that they jump up amongst levels, and inside atoms they're like a block of apartment block, different levels, floors. So your electrons go up to the top floor and then they fall out and they come down, and when they fall out they give off energy, and that energy comes out in the form of light. So you see the light. It's a change in energy when we have a chemical reaction. Now that's gone over all of our heads. Myself too. I tried to study that stuff when I was in college and it's like, no, not for me, man. So I came and did other fun stuff. So we're going to do another chemical reaction now. Everyone at the table is going to get an ice pack. Right. Every table has an ice pack. When you shake it, what do you hear?
What do you hear?
What are you hearing?
It's not like powder.
Right, I'm hearing we've got a kind of like a powder in there. And if you feel it, what do you feel? Did everybody have a feel? Did everybody have a feel?
No.
Has everybody had the ice pack in their hand?
Yes.
We all heard it shake like a rattle.
Yeah. Everyone had a turn.
Alrighty. What else can you feel inside the ice pack? Okay, so we can feel like pebbles. Did it feel like there could be some liquid in there? No? Yes, okay. Alright, so who has squeezed it so hard that they've broken it already? Is your one rattling still? Oh, it is.
What?
I thought you broke it. Okay, now we're going to break it.
Oh no.
No. So what you do is you take it and you squeeze it as hard as you can until the little bag inside pops.
Oh my god. I'm kind of squeezing it, but
Yes, it's kind of worked, right? And then you shake it, right? Once you've broken it inside, shake it. And then what's happening to it?
turning into a liquid and freezing ice.
Share it so everybody can feel. Did yours pop? Did yours pop? No, not yet. There we go. And we shake it, shake it, shake it, and what does it feel like? Wow, it got really cold. Did everybody's pack go hot? Did it go hot? No. It went cold. I'm just checking if you're paying attention and listening. All right. So why do you think it went cold? Oh, you guys are always volunteering. Back table. Okay, so kind of maybe sort of almost right. Okay, so it didn't go, it wasn't ice because if it was ice already it would be cold, right? Okay, but definitely there were some beads in there, some crystals in there. They didn't melt because it didn't get hotter. Things melt when it gets hot. Okay, they dissolved inside the liquid. So there's actually ammonium chloride crystals, which is a chemical, in the sachet in the bag, and there was liquid around that, which was water. And as you dissolve those in water, they need energy to make that dissolving or that dissolution happen. And that energy comes from the surroundings, and we feel that as the packet going cold. It won't stay cold forever because eventually the room temperature will warm the whole packet up. And then it will lose the temperature and come up to room temperature. But they're temporary ice packs, so they're used in the medical. You can use them if you have a knee injury, if you have an ankle injury, if you hurt yourself, and put an ice pack on. That's what you can use instead of having to go to the refrigerator or the freezer. Alrighty, any questions on that one before we really have some fun?
Okay.
Wow. Alrighty, so does anybody have a snake at home? Got snakes at home? As a pet snake? Alrighty, so for the guys who got pet snakes, this won't be too exciting. We're going to make water snakes.
Is that water?
Nope, it's not water. That's why I'm wearing gloves and goggles.
Is it bleach?
It's not bleach.
See a few minutes.
Wow. Let's just make another one.
Alrighty, so what we're going to do is I'm going to come around with a special goo to each table, and we're all going to share nicely, and we're going to put in drop it in slowly, and then we're going to drop it in, push it in a big squirt, and be careful because the water snake's going to jump right out the water at you. Alrighty, are we ready?
Maybe, I don't know you.
Alright, so you're going to drop it in drop by drop into the liquid. Go for it. Take it and don't put it on the table. Drop it in slowly. I don't see any snakes jumping out yet.
Volcano said I still do not know how to make dogs.
We just go slow.
Keep going.
Okay. What is wrong? I don't know.
When he's done, okay, squirt it in and see what happens.
Do I squirt it slowly?
Push it in fast.
Oh, dang it, it's dripping. It's dripping.
That's okay. Right, you go. You try. Go fast. Keep it in a constant stream.
Yeah, go fast. Hold it up.
Alrighty, let's go.
Squeeze harder. There you go.
Alright, hold the bulb and just let it fill itself up.
Oh, we already have one.
Yeah, but you don't have any liquid. Nothing's happening. Alrighty, there you go.
Oh, you can hold it.
Right, off you go. Put it in there. Drop that in there. Start dropping it in slowly. I'm going to drop it on the table. Take it.
Can't let it go yet. Let's not
Okay.
dropping it slowly.
Oh, no, he's squeezing it quick. Gosh. You got any snakes in there yet?
We can tell you about snakes. I got one.
I'll swap you. There we go. There's your stuff. Alrighty.
Just watch what happens.
So did you guys catch any snakes yet?
No.
Oh man, do I have to come fishing everywhere? Oh my God, you got a snake.
Can I do that?
Yes.
We have one fruit.
I got a water snake.
I squeeze all of mine.
We got two snakes.
Lucky you. Look at that.
This is another experiment.
How many snakes did you all get? Huh?
Can you make this at home?
Could I make it?
Can I make this at home?
No. No. Oh my God. Alrighty. Very good.
This thing is hurting my hand.
Well, don't play with it. If it's hurting your hands, don't play with it.
What happens?
Nothing should happen. So there are other things. We really value STEM as an organization. As a responsible community partner, we have a social responsibility to work with our community, and this is a great way for us to give back into our community, to engage with our kids in the schools, to engage with our 2 school districts locally where we are located in Hardin County, and it gives a great way for my employees to come out and engage and to see people and to get our name in the community and answer some questions that folks may have about what we do in Elizabethtown. Did everybody get a water snake? Right. Okay. Was that cool or was that cool? Alrighty. Wow. Alrighty. So, can anybody have a guess? Was that a physical change or was that a chemical change? Chemical? Physical? So I took one liquid and I took another liquid, and what did I make?
Solid.
So is that chemical or physical?
Physical.
And it's a physical reaction because a chemical reaction took place.
It was a chemical reaction.
It's both. All right? Cool. All right, so while you're playing with your water snakes, we're going to start doing a little bit of tidy up and clean up, but let's think about what did we learn today? All right? What did we look at first? What did we put in the container first? And what came out of it? Yes, young lady.
We put dry ice in them first.
Yep.
And then gas.
Gas came out, correct. Did the gas go to the bottom or did it float up to the top? Okay, so we learned that things go from solids to liquids to gases, and in some cases, like dry ice, they go straight from a solid to a gas. There was no liquid in that container, right? So that's an important thing to know as well. So sometimes things can go from a solid straight to a gas. That process is called sublimation. It's different to melting, it's different to boiling. After that one, we then took the ice packs, and we saw a chemical reaction that was endothermic, which means it got cold. When we broke the packets inside and we mixed the two chemicals together, we saw a chemical reaction that gave off light when the energy was released, and that's called a photochemical reaction. And then we saw a chemical and a physical change when we mixed sodium alginate with calcium chloride, which is what we did right now when we made water snakes. Now, everybody's played with your water snakes. You can't take the water snakes home. You can't play with them all day. So what you do with them is you hold your palm out, your hand out, you put your water snakes in the palm of your hand, right? And then you take the back of your glove with this, take this hand and grab your glove here and peel the glove inside out with your water snake inside the glove. Oh, and then put that glove inside the other glove, like on the palm of your hand, and then turn that glove inside out inside the other glove, and then we'll have your water snakes in your gloves. If you're interested in following up with us and finding out if we'd come out to your school, please work through your school district and give Nancy McCoy at Dow Chemical a ring, or you can call me on 270-706-8150. If you're with Hardin County Schools, work with Terry the superintendent, or with E-Town Independent, work with John Ballard as your superintendent.